Okay, we'll go ahead and get started. All right. So, just like the other day, we're gonna do a little bit catch up. I'm gonna try to get through two modules today, and then we'll be caught up with where we should be. So, today we're gonna be covering the X cross-site scripting, file inclusion, and then SQL injection. And then I dropped this in chat, so we have all the corresponding labs for this. So yeah, we'll try to get through these two today. So yeah, hopefully I won't go too fast on them, but yeah, that's the goal for today. All right. So we'll go ahead and get started. So this is kind of continuing on the offensive security side of things. We talked a bit about operating system exploitation with Linux exploitation, Windows exploitation, and then this one is going to be more focused on the web application attacks or website attacks. Yeah, so first one here, cross-site encryption and cross-site scripting and file inclusion here. So some important thing to kind of understand with how websites typically work. So the other day we talked about how originally websites was static content. Um, most pages weren't very interactive. And then, as things started shifting into, what we call today Web 2, where it's more interactive, there's dynamic content. This dynamic content needs to, essentially perform programming logic somewhere. So, with that, we'll be looking at what's called client-side scripting or client-side web languages. And that's I'll kind of show these two different diagrams here. So there's all this programming logic needs to be performed on a computer somewhere. So some of it gets performed on the server, and in this client-side scripting, a lot of the web requests is actually happening by your web browser. So, in this diagram right here, we have the top left, the internet. We have the little server-looking thing, those three rectangles, and then everything to the right is it should be representing pretty much your monitor. So this is where the server is sending a page with these client-side scripting languages, and your page is actually doing all the parsing, all the programming logic on your computer, and then sending responses based on what you type, what you click, all that back to the server. So in this example, it's called client-side scripting. Um, Versus on the right here, we have what's called server-side scripting. So, the simplified version of what we just saw on the left is everything's happening in the browser. On the server side, scripting aspect is where the programming logic is happening on the back end on the server, and it just serves you a static page. So, and there's pros and cons to each of them. But I would say, that's when you're doing all this thing on the client side, you're actually trusting the client's computer to perform the actions that it was intended. So, the server is sending off code to your computer. The browser is going to be, taking this code and performing some actions and sending input back to the web server. And by design, it should work just fine. And that's we'll talk a bit some about this different client-side languages. But in a nutshell, this is what's get exploited. Where anytime you trust the client to do something, this is where hackers are going to be looking to manipulate things. So these next few slides talk about some of the client-side languages. Just like everything else, where the intent isn't for you to, become an expert on this language or any of these things in one slide, but just to kind of get an understanding of, what makes up client-side languages. So the very first one here, hypertext markup language, HTML. This was essentially like the roots of the World Wide Web right here. What you see rendered, on the right is your HTML markup language. At its roots, HTML is just displaying text, images, media, and telling your browser where to put it, what size to make it, what font, what color, how big is this image going to display, what's clickable. All these things is what at its roots of HTML. What you're seeing right here is like the very basic HTML. I think the latest iteration of HTML5 is pretty dynamic compared to what you're seeing here. But in a nutshell, HTML makes up where how the web pages are built on the internet. Um, Typically, working with HTML is something called CSS cascading style sheets. They basically help make consistent layout across a web page. And the reason for doing this is you don't just typically have one web page. You typically have multiple web pages. You have, you click, you go onto another web page, and instead of telling in coding into each web page what color something is, what size something is, what kind of text it is, you just make one style sheet. You give it all the colors, the font, all that stuff, and then each page you make, you link it to this style sheet, and it just kind of helps create that consistency, um, less administrative overhead, so you can kind of link everything to a style sheet. If you want to change a color, you change it in the style sheet, and then it cascades to all your web pages. Essentially, why it's called cascading style sheets. And then JavaScript. So this is one of the early languages of the web that did all the dynamic programming languages. So, HTML here, it's just formatting. It's text, image, media formatting. HTML can't really perform too much programming logic. You can't say if a user clicks this or a user types this, do a certain action. Similar to CSS. CSS is not dynamic at all. It's just defining colors, appearances, and that's where JavaScript comes together with HTML and everything. And this is where all the where you can put in some of the fancier things or the interactive things into your web pages. So and Java, again, this is very basic JavaScript. JavaScript's survived quite a while, and it's lives on web pages today pretty heavily. And this is a little off right here. Okay, there you go. So, and this kind of summarizes it all together. HTML is the structure, the CSS is the style, JavaScript is the interactivity. Important to note that this is probably the biggest market share of what makes up web pages, but there's other languages out there. We'll touch on a little bit of them, and we're not covering too much of the server side aspect of things today, but this is a majority of the client side aspect of browsing the internet today. So just briefly covering other ones, TypeScript. I've never done anything in TypeScript, but it's it's a superset of JavaScript, and right here it says it helps developers catch errors. So looks very similar to JavaScript, but I can't speak too much on the pros or cons that well here. jQuery. So this is a popular library, and every time you see DOM right here, so it's document object mod. I want to say module. It's basically it's referring to the web page as a document, and all the different parts of a web page are objects. So they call that DOM. And things like mouse clicks, mouse over, form fields, all those things are different, what they call DOM objects. So jQuery is just a library for make that some people feel is a bit more easy to manipulate these objects within a web page. Again, I've never ever, having gone too far down the path of being a full-time web dev or anything like that, but so I can't speak too much on the pros and cons from a developer aspect. But again, we're staying on the client side scripting. All of these things, when people develop a web page, they're sending all this script to a web page to your browser, and your browser is then performing these actions. There's a few other JavaScript frameworks to call out, and I want to say one of these is developed by Google, the other one by Facebook. I'm not sure off the top of my head which is which, but some other popular frameworks that live in the client side scripting space. Again, not just to introduce, if you hear Angular JS, React JS, Vue.js, these are all different types of frameworks that web developers will be developing applications using JavaScript with. So, and as you can see, there's some differences. They some have claim to have a steeper learning curve. Um, some of them claim to have different mobile support aspects of it. All in all, I think if you're developing individually, you write what works for you. And then if you're working for a larger organization, there might be strict adherence to we use X framework for everything. So it all depends. I think uh, I've seen people argue why one is better versus the other many different ways. Something else that I'm not very familiar with, but there's something called WebAssembly. Basically, it's an ability to write code using these programming languages that you typically don't see for web development. You see, like, we have C++, Rust, things like that, and it will actually create them into these different formats that are, operating system specific, whether it's going to render on Mac, Windows, or Linux, or anything like that. So, a bunch of these, all of these essentially are, writing code that's going to be run on the client. And, why is that important? Because um, basically cross-site scripting is taking the code that's being sent to the browser. And this is where a hacker uses a program to manipulate how the code is run and actually sending it back to the web server by manipulating certain fields. So, this example, um, you know, the uh, the web server is expecting the code to be run as designed. In this example, you know, because of certain security flaws on the web server, the attacker can manipulate how the scripts run and actually inject malicious code into the website. So, um, in the example right here, this would be maybe like a blog page where the maybe we have an author. Their job is to write articles, right? They're not a web designer per se, so they get an account on WordPress and they log in, type their article, and they're just operating it like it's a word processing program. And on the back end, it's the website is doing this all with maybe client side scripting. That it's rendering JavaScript to the author's browser, and the author's typing in all this input, publishes the blog, the article. That was the intended design. If there's a vulnerability in that web application, the attacker can take advantage and actually input malicious code into the website. And instead of publishing a nice article for users to read, it might publish an article that might actually have malware on the web page. So anytime basically you're manipulating client side code and that server isn't, has a vulnerability, this is where a hacker can go ahead and inject malicious code. And this is the general term for cross-site scripting. We'll talk a bit more about the different types. So same example as the first, so there's a few different types of cross scripting. So this is stored persistent cross-site scripting. Again, my example I keep bringing up is pretty much any page that allows for user input that will be published and displayed on essentially the World Wide Web is where you see persistent XSS being leveraged. Other good examples, Reddit, any user forums where multiple users are contributing to things that will be displayed to other users. Reddit's a good example because they actually are pretty secure. If you were to type in, if you were to try to send, a link to, something to run on other people's browsers, Reddit does a pretty good job of filtering that out, sending an error, and actually blocking that from being published to their websites. But there's a lot of old examples of or there's a lot of examples actually still today to that. So like I bring up WordPress because WordPress always comes out with some sort of vulnerability where they allow this kind of stuff to happen. Um, Something that's a little more sneaky. So um, it's called a reflective cross-site scripting attack. So this is where maybe it doesn't necessarily write to a victim's to the web page, but for example, there's a bank, we're using a bank for an example. Um, the intended access for, I'm a customer and I'm, logging into my account on the bank's website and performing legitimate transactions. There might be a vulnerability in those interactions where maybe if I'm the attacker here, I'll craft a link with certain, you know, uh, I'll add some strings to the link that will actually perform certain functions. Maybe it'll initiate a transfer to my bank account, or maybe um, it'll send my login credentials to the attacker, and then the hacker can log in as me. So anytime there's um, a way where you can have a legitimate user perform some kind of action that will benefit another user. And it's sent via a link or something like that. Would be what's called a reflective XSS attack. So it's not it's not publishing a page to the website, but it is still performing a malicious function that's not intended. So, and this is where you want other users to do these sort of things. Not on the slide here, but I've seen combinations of this sort of thing. Somebody will craft a link that would perform fraudulent transactions to a bank site, and then they would like push it to a blog or something like that, and people would eventually click it, and next thing you know, there multiple people are performing a malicious transaction, or multiple people are sending their bank authentication to an attacker, things of that nature. But yeah, all of these again certain intended functionality is supposed to be run on the browser. It's being leveraged by threat actor to push this sort of things to the web server. So how do you mitigate this? So just like any type of input, like if we're talking about a form, you want to make sure that certain command strings, like so in this example, we have this link where it's the bank.com, and in this little quotations where there's evil-attack.js. You'd want to make sure that certain characters or certain things would get filtered out of the input coming back to the server. So, maybe in this example, we'd want to throw an error message if the client is sending back like a web page within this P1 value or something like that. Or maybe we want to limit what kind of special characters can be sent back to the server. That way it would negate something like this, similar to this example right here. The attacker's sending, it's fictional, but this malicious JavaScript where maybe we want to filter out certain strings or characters. Maybe we don't want to, again, it's referencing a script at hacker.com. Let me zoom in all the way. So things like that, you don't want to just have the client to be able to send, any unlimited amount of characters. You want to, limit the what input can be sent back to the server by the client when you're anything that's being performed in client side in these aspects. So, input validation, sanitation, those are all covered into, making sure that the attacker's not sending, characters, strings, values that it's not allowed to. Content security policy, this might be, the one example had like an image file being sent. So maybe you want to say that client side input can't have media files, something of that nature. Escape output. So it's certain characters that are called escape characters. Maybe within JavaScript, it might be double quotes, things like that. So you might want to filter out certain characters from being sent back to the client. So um, all these things are good ways to, make sure that the input coming back to the server can't be, you know, manipulated maliciously. So that's generally how you prevent these cross-site scripting attacks. Um, so moving on to the next type of web attack, session hijacking. This is very similar to some other types of attacks that you've seen for like Windows. In Windows, it was pass the hash attack. Essentially, you log on to a website, you know, um, it's starting a session. So like if I log onto my bank or social media, I'm not going to have to type in my username and password for every page that I interact with after I log in. That first login creates a session ID or some kind of session cookie or something. And that value is used to determine I'm the user that authenticated. Typically, it'll have some sort of expiration, something like that. And that's how we manage sessions whenever somebody's logging into a web application. Now there's many ways that attacker can do some session hijacking. Of course, if they're on, the same Wi-Fi as you, or if they're somewhere within the traffic flow and it's not encrypted, they can likely um, intercept this session ID. In this example right here, it says session ID ABCD. Of course, realistic example will be a much longer, more randomized type of string, and possibly, maybe it's hashed or something like that to add some level of security to it. But in the end, if an attacker's within your path after you've authenticated, there's a good chance for the session ID to be hijacked. And this can be, I'll be able to just, if I've hijacked your session ID or session cookie, in theory, I can craft a HTTP message to your bank or your social media, and then I can interact with your session ID as long as I do it with before the session expires. Um, basically, and basically what I said here, and in this example, it calls out document cookie. Um, Earlier, I referenced in JavaScript, there's the document object model. Document cookie is one of those things that is a standard place where I don't think we talk too much about cookies, but and nowadays whenever you go to a web page, I think because of maybe GDPR or some other compliance requirement, you go to a web page and you have to hit accept for almost everything. Kind of you're agreeing that certain cookies are going to be stored on your computer about a website. Um, and that's kind of typically where we see session IDs get stored on your computer. And these session IDs aren't just for authenticating your user session. They could be something more simple. Just you log on to a website, not log on. You just browse to a website, and sometimes it prompts you like, what region are you in? Are you in US? Are you in EU? And then it stores a cookie to next time you browse to that website, it's not going to prompt you again. Or maybe you haven't logged into a shopping website, but you've clicked add to cart, something like that. Like there's sessions almost always created whether you authenticate to a website or not. They just want to maintain that user consistency with your session. Most of it has got monetary reasons behind it, where they want to keep your cart active, so you can, next time you browse to the site, they'll prompt you, be like, oh, do you still want to buy this? That's likely because there's a session cookie there. So not all session IDs are tied to you logging in, but in this example, you've logged in and the attacker's stolen your session ID. Um, so I mentioned a few of things like that, how your session ID could be stolen. Like I said, a packet sniffing. Maybe you're on the same Wi-Fi, it's not encrypted. Maybe somehow they're within the network path of your authentication scripting. We talked earlier about cross-site scripting. In this example, um, maybe the reflected thing is you click on the link and you send your cookie to an attacker's email or attacker web page. So that might be another example of how they can steal your cookie, and now they can log in with your session ID. Um, and then I added this one right here in the bottom, malware. There's a lot of malware nowadays. Um, I've been seeing like a trend, like fake CAPTCHA. Maybe you browse the web page and it says, verify you're a human, download this program or run this command. Users go, okay, let me do that. They run it on their browser, and then what the malware basically does, it just unloads all your document cookies off to the malware server, and we're seeing a lot of cookies or session IDs being stolen that way. So I think malware right now is the biggest way we're seeing session cookies being stolen by people, and then they take these cookies and try to log into banks, social media, things of that nature. um, so yeah, I think how it normally works. Like I said, they one way or another, they've stolen your cookie, whether they've intercepted it from the network, whether they've got it from malware on your computer. Basically, that document cookie object can then be, the you log in, you authenticate, you have a session. Then on the bottom arrow here, pointing the server, the attacker logs in with the victim's session ID, and now they can interact with your session. Um, so how to prevent it? There's a few things here. So basically, we talked about intercepting it. If you're on a page that's not HTTPS, all your cookies are going to be transit in clear text. So you definitely don't want to have a web server. You don't want to be browsing to a page that's not HTTPS. So that's the first one. There's something called secure cookies. Again, I've never been like a full-time web dev or anything like that, but my understanding, secure cookies are cookies that have a few extra fields that are that are unique to your session. So in addition to simply having a session ID, the cookie might also say session ID plus the IP address that did the authentication, or it might say the host name of the computer. That way, when the attacker steals your cookie, it's not going to have all the same unique values that I had when I authenticated. So in addition to having the session ID, I might have to have a matching IP geolocation or some other thing that's unique to me when I authenticated that would kind of create that quote unquote secure cookie. In the end, though, a crafty hacker, we're still trusting client side communication. If they figure out what values are sent with it, they can just send that to along with the session. So in the end, you don't want your cookie intercepted. In the end, you don't want malware installed on your workstation that's going to steal your cookie. So, you know, antivirus should be definitely on this as well for, how to prevent session hijacking here. Um, Rotating session identifiers. Like I said, all of these have some kind of expiration. Banks nowadays, they're pretty quick. You get a little pop-up saying, are you still doing stuff? Click continue. What happens when you do that? It's typically refreshing the time to live on your cookie, your session cookie. So, but a long time ago, this is something that you would see cookies that live for days. You maybe even weeks or months. There are some sites that you may never log into for forever, depending on how long that session cookie is. Again, I think like I said, banks, they've got a lot of compliance requirements, so they'll typically have a very short-lived cookie. Multi-factor depends. I think you when you first authenticate, that's when you're going to get prompt for that multi-factor. Um, there might be some kind of combination that you should use if you're developing this. Maybe you say if the cookie changes the source IP, let's prompt for multi-factor or something like that. And in the bottom, IP address, user agent checking. that's kind of what I've been mentioning along with secure cookies. It could be something as maybe the browser user agent changes and it will prompt for reauthenticate. So all these things are good ideas to kind of detect and or prevent session hijacking. Something changes about the session. Let's reauthenticate the user. But I would say a lot of older sites and not every site has all these things. So um, yeah, definitely stay away from malware and unencrypted connections over public Wi-Fi's. Those are hotbeds for cookies being stolen. All right. So we talked about cross-site scripting and session hijacking. Another type of attack that web browsers can typically be vulnerable to, and this is called local file inclusion. Um, so this is something that has more to do with the server config than maybe the client side application. So, we talked a bit about, scroll back up here, client side versus server side. So right over here we have programming logic that's running on the server itself. Depending on how that server is configured, the server is basically an application and an application user running on the server itself. So in this local file inclusion issue, it's where the application or server may not be configured to securely where it allows you to access files that are on the server itself. So, in this example, an attacker might be able to, if you remember back to Linux command line, if we do cd dot dot, we go up a directory. So in this example, what we're telling the web application is, hey, let's browse to dot dot slash dot dot slash dot dot slash dot dot. It's basically saying go, back a directory until we get to the root, and then let's go to the etc password file. So if this server and application is not configured correctly, the web page will display the files that are here, and you can essentially browse any local file that's on the server. And in this example right here, if the web server can access etc password, etc shadow, you can then copy the hashes for all the users on the server and then go ahead and crack them. Or maybe there's other interesting files on the server that can be accessible. So yeah, poorly configured web server could definitely allow this sort of thing where you can get access to the root password, all sorts of things. And of course, you know, manually going through something like this could be pretty difficult to figure out. Uh, so of course, there's definitely automated scanners that will look for something like this. There's a good number of them out there that will automatically start trying to do directory traversal onto your web server to see what files it can browse to. Um, and then local file inclusion, I would say input validation depends. In this example, we're doing it directly into the URL, so there's no input to validate. But just as well, there could be like a web form that's that could allow some kind of directory traversal as well. So if you have a web form, where that's looking for a username, password, or looking for maybe you upload a file, you definitely want to have this input validation filter out, directory traversal characters like this. Maybe there's no need for forward slash or other types of escape characters like that. So input validation may or may not apply. Um, let's see. And a lot of these are web server configurations like limiting file access. So any web server I'm running, whether I'm running it on my Linux machine, my Windows machine, that web server is going to run as a service account or a user account. You definitely don't want that web server to have, read access to every file on the workstation. You want to limit what it can read, write to files on the web directory. So that part, a good chunk of this is just configuring, making sure your web server is running with the appropriate level of privileges. I've seen many times people, they stand up a web server, their web server is running as root, and that's typically where we see this happening. The root account has read, write, execute access to every file on the machine. So if there's any leniency in the application, they can do this local file intrusion. They can do directory traversal. They can do a lot of damage to a system. So yeah, I think limiting file access slash least privilege is probably one of the best things here. All like disable directory listing, those are server configurations as well, but you definitely want to make sure a web server doesn't run as root, run as administrator. It should just run with just the permissions it needs to run. All right, so that's it for cross-site scripting and file inclusions. Like I said, we're gonna try to get back on track with SQL. We will cover SQL injection, and then we'll be back on track for where we are supposed to be in the course. With that, before we take a break, any questions on XSS and file inclusion for now? All right. And I'm pretty certain, yeah, like for the labs, there's going to be using the Kali Linux and the I want to say the Metasploitable box. There's some pretty good labs on doing the cross-site scripting attack as well. All right, we'll take, let's see, about 12 minutes. So we'll start back up at 6:10. So we'll take a little break here and get back started with SQL injection. Right, we'll get back started. Just a quick audio screen share check. Good to go. Thank
Yeah,
you. All right, so we'll get started with the SQL injection, and then we'll go over some of the upcoming labs here. So, all right. So first off, we've done a bunch of slides here and there that kind of talk briefly about SQL injection, and again, like most things, we'll just do a brief intro on what SQL is. Again, you're not going to be an expert on SQL in just a few slides, but we'll talk a bit about it before we talk about the SQL injection attack. So, SQL, Structured Query Language, is what it stands for. Basically, we have, uh, you know, databases have evolved quite a bit. I think you can think of something as simple as Microsoft Access. If you ever use that, really difficult productivity application, that's more of a static database. With the Oracle, MySQL, Microsoft SQL Server, those were essentially commercial grade databases. Typically called relational database management servers, or RDBMS. Um, and the reason for this SQL language is, it's kind of designed for, with it being commercial grade, not necessarily having users typing in fields one by one. Meant to be, where applications could be able to interact with um, a central database and perform certain things, in of course in a quote unquote structured way. So these languages are developed to kind of essentially interact from a machine to machine perspective in most places. However, the language still needs to be human readable, human understandable. That way, one, we can build that programming logic in place, and then two, if we still need to do manual manipulation. So, SQL exists. For the most part, all these different RDBMSs, MySQL, Oracle, Microsoft SQL, have a pretty consistent structure for their SQL commands. But like anything, there's always going to be some slight variations between Microsoft, Oracle, MySQL. And the the screenshot right here is a little excerpt, a sample of some SQL. Um, with the websites, MySQL seems to have uh, taken a large part of the market for smaller individual websites. MySQL was free for as long as it's been around. They've had a free community version of it, and then as well as professional for people who want to have that professional services, professional support. So if you wanted to, you could stand up a web page with the database backend using MySQL for completely free, for no MySQL license required. Um, Postgres, I think, is also free. Um, Today, there are certain versions of Microsoft and Oracle that I don't know seem free, but to most part, Oracle, Microsoft typically are deployed with commercial corporate type of deployments. Um, with that, in this example, you can always think of a database as an Excel table. That's a table in one database. These RDMSs have multiple tables and multiple databases, multiple users. So one database server can support multiple applications. That's SQL RDBS in a nutshell. From a web perspective, going back to client side versus server side, almost always if there's a database interaction, it's happening with server side scripting. So um, the super common thing on the internet is what we call the LAMP architecture. So LAMP is for Linux, that's your server. Apache, that's your web application. PHP, that's your server-side scripting. And MySQL is your database. all of which are free open source applications that you can install. So, you know, back in the day, people, if they wanted to stand up a dynamic website, they could just open up a port on their router, have a Linux server, install all of this for free, and you can be up and running, for the cost of having your internet service provider. And or, a lot of universities, they let people run this for free. And of course, if you wanted to, you can pay like a hosting company like GoDaddy or anything. And this is a pretty standard architecture setup. So in this setup, you have PHP running on Apache that's interacting with MySQL. And that's where those SQL queries are happening. The browser here on the left is sending a web request to Apache through the PHP server-side scripting, and it's executing those SQL queries between that interaction there. Now, like I said, this is one architecture. If you're running Windows Server, it's likely going to be, instead of Apache, it would be Microsoft IIS. Instead of PHP, it's going to be ASP.NET, and then instead of MySQL, it's going to be Microsoft SQL or something like that. So, but this is probably like this most common database infrastructure you'll see for web applications out there. So there's two forms of SQL commands. One is called DML, data manipulation language, and DML is where you're actually writing or interacting with data in the database. And here's like the first one. We're just querying information in a database. We're saying select first name, last name, age, and then from is the table. So in table employees, and then you can just leave it at that, and it'll just pull everything. But typically, you want to actually define some sort of discriminator. So where department equals IT. So I'm in this example, I'm running a query from the employees table, and I want to get their first name, last name, age from the IT department, and I want to order or sort by their last name. So this is your basic select statement. This is you can get really complex with it here, but it's the most basic select statement. And again, this is part of the DML subset of SQL, so data manipulation language. Insert, this is where you are actually going to be adding data to a table. So this is where in this example we want to insert into the products table, and in this first section you're saying which column, so product name, price, and stock quantity, and then the values. It's all going to be comma separated. So first one is going to be product name smartphone, price is $599.99, and stock quantity is 100. Quick call out here. So as you notice, this first one, it's got quotations, so it's a string value. Just like kind of Python, there's different data types. The second one is going to be float value 599.99, and this last one is an integer 100. When you create the table, these fields are typically defined. You'd get an error if you try to insert a string into an integer field or vice versa, something like that. You'll typically get an error. So inserting creates a new row, and here we have update. Update is where you are looking at an existing row and you want to change a value. So we have update the employees table, set the salary column to 50,000 where department equals sales. So it'll update it, and as much rows meet this value. If you leave it, if you don't add this where statement, it's going to update it for the entire table. And in this example, maybe we're saying everyone in sales is going to get 50K a year or something like that. So that's the update field, and of course delete. For the most part, pretty obvious. We're deleting from the customers table where last purchase was, prior to January 1st, 2022. So that's one example. Just like anything, I would say SQL queries aren't going to ask you if you're sure. So any one of these can be pretty damaging if you're not quite careful with how you operate with them. Um, so we talked about DML. So manipulating data, DML. Um, right here, DDL, data definition language, is essentially the structure of a database. We talked about here. So this is where we're defining the structure of the employees table. So we're not actually inputting any data, but we're formatting, we're creating the table. So in this example, we're creating the employees table, employee ID, and we see int. We're saying it's an integer. First name, varchar, it's for various characters. It's like a string value. Last name, it's like a string value. Then salary, we're saying decimal. So that's similar to float, where we're saying up to 10 characters, and then we want to see 2 digits after the decimal. So this is an example of creating a table. Important thing to call out with SQL or DML in this particular case, every table needs a primary key, and that primary key is a unique key. So you can't have, so in this case, employee ID. It won't let you create another row if the employee ID already exists in this table. So something that every table well, there's of course exceptions to everything, but for the most part, every table in a database will have a primary key that's unique. So yeah. Mm. So that's just the gist, very basic SQL things to understand. So SQL injection attack. In these examples, so a web page, whether it's a form, whether it's a or whether it's a page that is just simply querying data. If it's a dynamic page, it's got, like anytime we load a store website, it's looking at a database to see what's in stock, things like that. And then somebody buys something, it's going to manipulate the quantity or something like that. And, it's doing this all like, depending on how busy it is, 100 times a second, 100 times a minute, whatever it is. So that's what's supposed to happen. Now, where SQL injection, occurs is where, an attacker can manipulate something to inject an SQL statement, and that gets run by the web server to the database, and it'll perform, and that database will perform whatever that command is. So in this example right here, we have a teachers.com webpage, and the intended command that the application is going to run is, maybe it's saying, show me this teacher, whatever teacher ID 117 is. Then the attacker adds in this or 1 equals 1. So when you add in that or 1 equals 1, you're basically saying, show me this teacher or everything, or if this value is true. So it's going to actually show you data for all the teachers. And that's just one example of a SQL injection attack. So, at its roots, SQL injection, you're manipulating the web application to send the SQL command to the database server. And there's various methods and ways it can be done. So common injection points, that example is a URL. Forms are extremely popular. Almost anytime you see a form, a page is interacting with some sort of database. If you log on to social media, you log on to your bank, you log on to a retail website, we're interacting with a customer table, we're interacting with the user table. There's all sorts of tables that are, in a database that's getting interacted with. So you almost always know that a form is going to interact with a database, and that's probably the most popular place you'll see it. Less common is everything you see below that. Anywhere that an application interacts with a database, there's possibility for SQL injection. So maybe based on a cookie, it interacts with the database. So maybe you manipulate your cookie. There's all sorts of things, but the general thing, and in the examples in the lab, it's going to be, you'll be manipulating a form to do some SQL injection. Quick different variations of SQL injection. In this first example, we're only interacting with one table. Depending on how your database is configured and what you're vulnerable to. In this example, The website is designed to interact with this products table. So we see select name, description from products where category equals gift. And then the attacker, through some testing reconnaissance, says, I'm going to add in union select username password from the users table. So this union command is actually an SQL command that queries from two different tables in the same database. So, this web application was designed to interact with the products table. So the attacker injects select username from password or username password from users table. And in theory, this attack is going to display all the users and passwords from the users table. That's a realistic way for this sort of thing to expose all user credentials. Hopefully those passwords were encrypted or hashed or something, not stored in clear text. But yes, that's definitely happened with some realistic examples in the past. So I'll talk a bit about a few things and I'll piece it together. So Boolean SQL injection. This is simply adding in true or false. So I might want to say, maybe I don't know this user table exists, right? So first thing I'll do is I'll say blah 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 union, select users, and I'll get a true or false value back or something like that. That's one step in an attack process. Error based. So depending on if maybe the table doesn't exist, you'll get an error back. All these little things are, little steps to help you because you don't know what the database structure looks like in the back end. If you're the pen tester, the hacker, you're somewhat taking some educated guesses, or maybe you're just blindly trying to interact with the database in the back end. You didn't design it. You maybe have a general idea what this application is, users, database, products, all these things, but you're working from the what we call black box. You don't see anything on the inside. Time based. So um, you hit submit on your SQL injection. You get an instant reply back. That might be an indicator that table doesn't exist. There was an error happening, versus you hit submit and it takes a while. That might give you an indicator that it's a very large table. It's taken some time to return the data. Maybe it still errors out, but you've gotten a little somewhere. All of this kind of leads to what we call blind SQL injection. So sometimes the web page doesn't always return the actual database values and things like that. So blind SQL injection, you use these little stimuli response to gather what's the names of the tables, do they exist, things of that nature. Now, just like with the local file inclusion, um, this could be very difficult and take a very time consuming to do manually. And of course, there's tools out there that do this right here. So a lot of these tools will kind of start doing, like SQL Map, this one on the top, really awesome tool for testing SQL injection. It'll perform a number of SQL injection techniques, and of course it returns it back to you. Then you get to just see all the data. Great. But SQL Map will perform those blind injections, and it'll test for users table. It'll test for all sorts of tables, or it can even kind of brute force test. Does AAA exist? Does AAB exist? Things of that nature, and through whether it's successful at typical SQL injection, or whether it has to perform hundreds and thousands of blind SQL injection attempts, it will actually map out an entire database if the SQL injection flaw exists on the web application. So yeah, you definitely don't have to do the blind SQL injection yourself to time how long it is. I mean, it's good to understand how it's working, but these tools like SQL Map will actually perform these functions for you with pretty good accuracy. And like I said, Kali Linux has this stuff installed by default. Um, Less common thing, I would say I'd never seen this in real life, out of band SQL injection. It says right here, certain cases, there's alternate methods to communicate with the database server. In this example, we have the web server connecting to the database server, and then there's an out-of-band service. So it's a much less likely, much more difficult vector, but always good to know that sometimes database servers have more than one ways to connect to them. So out of band may be an option. Another less common thing, sometimes the commands get stored and executed later. Something to keep in mind, of course, you're the attacker, you're the pen tester, you're on the outside looking in. So sometimes it's good to keep in mind that the right here says the vulnerability or the SQL injection may not immediately be apparent that it's working. So just something to keep in mind. Again, very uncommon. And a few real world examples. I'm not familiar with this one, but Sony PlayStation Network. I did read up on this one. This was an example where they stole. I think I got a breach notification for my PSN account as well on this one. So yeah, basically SQL injection was one of the methods that they were able to leak everybody's information to include credit card data. So yeah, definitely a real thing that exists out there. Um, Something else to call out on these tools. I've never, I can't say I've used them all. Um, Burp's out there. Burp has a free version versus a paid version. The free version, it's you've got to have a lot more expertise, but the paid version has tons of plugins for SQL injection. And then this Qualys one is essentially more like a vulnerability scanning type of thing. It'll just kind of report in, is it vulnerable to SQL injection? I'm not too familiar with a bunch of these other ones here. So preventing SQL injection. So first thing that to call out. So parameterized queries, prepared statements. So let me go back to this diagram here. So one of the safest things you can do is something called parameterized queries. So instead of my web application running in PHP here, telling my database server what SQL state command to run, at the MySQL level, you can create what's called prepared statements or parameterized statements. And it might just be something like I create a SQL query, I name it query customers. So in my PHP application, it's just going to run the prepared statement query customers. My SQL server is not even going to accept an SQL command from PHP. That's one of the most secure ways to prevent SQL injection. It takes a lot more admin overhead, trying to come up with every single command your web application is going to run against the database, but that's probably the most secure way to do it. Depending on how much time you have to build these things, probably not letting your SQL server accept SQL commands directly from an application, almost zero way that SQL injection attack can occur. So, one of the top ways to prevent it. We go back again to input validation, sanitation. You don't want your web forms to be able to accept special characters, SQL commands. This little table right here, kind of sums up all the different things. Remove unsafe characters. Check if the input meets certain criteria. So, for example, if the input is an age value, at the application level, you want to make it so it only accepts integers. If it's a zip code value, wherever you can, you want to restrict that data input to be as specific as possible to prevent somebody from typing in an SQL injection statement or cross-site scripting statement. All these things. Few other things to cover. Least privilege. So let me go back again one last time. This arrow between PHP and MySQL, there's going to be a user account associated with the web application. what database user is accessing the database. Again, so many people make the mistake. They install MySQL. You need an admin account. They then don't create a database account for their web application. Maybe now the web application is running with the same user that installed the database with full admin privileges. This application gets hacked, and then they can go and, instead of being able to only do, select or insert or update, they then have the ability to go and run DDL commands. They can, wipe out entire databases. Super damaging. So you want to make sure your web application has least privilege here. So to perform the very minimum, if if this application only needs to query, it doesn't need to update, delete, or anything like that. That should be the only privilege that the web application gets. So you give your database account for your web application the very minimal privileges. Web application firewalls. So I think we talked a bit about this previously. A lot of them, it sits in front of the web application before the command even hits your web server, before it hits Apache, Windows, PHP, and web applications have signatures that will web application firewalls have signatures that will block SQL injection attacks. It knows when it sees, equal, quote, or 1 = 1. This is an attacker trying to see if there's a SQL injection vulnerability. It knows if it starts seeing unions get added to a form field that this is not good. So web application firewalls will actually block it before it even touches the application. And at the very worst, so the last thing you want to do is have a free-form field where a user can generate their own SQL statements. Probably the worst thing you can have in an application is, oh, hey, user, what do you want to query the database with? Or, enter your database query in this field. And yeah, that's the last thing you want to have running. But those exist out there for various reasons. So, but yeah, definitely don't want any users to generate SQL statements on their own. Error handling. So one important thing is you don't want the error to be displayed to the user. You don't want to give the attacker help at crafting their SQL injection. If they're typing something in a form field and it's kind of triggering some errors at the database level, you simply want a generic error to be sent to the user. You want it to say, hey, input or input invalid, try again. Like, that's all you want it to say. Of course, on the back end, you want the administrators to see a different set of logs to see what triggered the error. But yeah, you don't want to give the attacker help. Like if it comes back and says oh, table does not exist, or something like that, the attacker's going to know, okay, well, that it's not called the users table, or it's called something else. Let me try something else. So you definitely want to reduce any of your errors, helping the attacker craft and make a better SQL injection attack. And defense in depth, web application firewall, all these things is, when you put all these together, least privilege, web application firewall, input validation, input sanitization, you're talking essentially about descent in depth. You want to defend it as much layers as possible. All right, that was a bunch to go through in 30 minutes, but we're just about caught up. Let me go over some of the labs for this week. They all seem like, I think, they should be working just fine. So all the labs this week, with the exception of maybe the last one, is going to be leveraging DVWA. This is Damn Vulnerable Web Application. So this should be running on your Kali box. So, for all of them, you'll open up Kali, go to this login page. It should just be admin and password. Whenever you run Damn Vulnerable Web App, you can go right here to this section, and you're essentially telling how difficult do you want this hack to be. For the purpose of this lab, we're going to leave it on low. But if you wanted to explore a little bit further, one DVWA is free to, while you're using this lab, you can crank it up and see if things still work. And there's a lot of documentation on the web out there. Like if you go to command injection, bring up this, and there will be a lot of references on command injection. So, the first one's going to be, this is representing a web form that lets you inject commands in there. So that's the very first one. So you're going to run a few commands to, show how you can actually um, manipulate files on the host to gain system access through a vulnerable web application. So that's the first one. Fairly simple one. The next one will be a cross-site scripting attack that will kind of represent one of the ones we went over. So again, log into DVWA, set it to low, and this one looks a little bit more realistic. It's web form, says what's your name, hit submit. And we're going to do a test run, and you're going to see if you can input some JavaScript. So if you can see if you can insert some JavaScript into the web page. So basically, the web page is designed to say, hey, what is your name? And it'll say like, hello, Ivan, or something like that. It doesn't have any input validation. So now you can go in and create a script that will run on the web page. So, you do a test one, it's going to just, give you a pop-up box. And then this is where you're going to do a more realistic example. We're going to, test stealing a cookie. So, one, you're going to set up a listener on your Kali box to listen for this cookie to be sent. And then you'll script this, you'll create this JavaScript. And when it displays, it's going to say hello, and it's going to have this broken thing. What should be happening in the background is your listener should receive the cookie. And it kind of gives you a real example of how your cookie can get stolen and sent across the internet to your attacker. So that should be a pretty good lab to test that out. Last, SQL injection. So same startup, DVWA. And just like the attacker would, you're to start off with a few tests. You're to do, the or 1 = 1, and you're going to see what happens. And basically, when it set it to low, it's going to send back basically whatever SQL command that you put in there, like if it's a vulnerable database. And from here, you can do some SQL injection techniques to just like in the examples, we're getting the users table and such. So those should be the 3 labs to get us caught up for where we should be at. All right, that's all for today. Just for reference, these are 1, 2, and don't do 3.1 just yet. We'll do this one. We'll talk about buffer overflows on the next one. So that's the 3 labs that should get us all caught up. All right, that's all for today. I know we had to go a little quickly to get us caught up. Any questions on today's content or the upcoming labs?
All right. So, yeah, if you have any question about the labs in accessing those issue, let me know so I can remind the lab admin right away. Thank you.
Yeah. Definitely let Joel know if you can't get into Kali or if the DVWA doesn't open up for you. So yeah.
I'm talking to Rodolfo right now about this, so just let me know, guys. Okay.
All right. Well, thanks all. I'll be available for a bit more, and Joel will be available as well.
Yeah,
And
I'm having also
see you
issue
all
with the
later.
class right now. So don't worry, guys.
Oh,
You're not the one who. You're not alone.
oh,
So I'm just
right.
talking to
Yeah.
Rodolfo right now.
All right. Yeah. Definitely DM everyone once it's resolved. Then Joel. Thanks.
All right. Thank you.
All right.